We left off talking about the shutdown point in the long run. And remember that the shutdown point in the long run is the minimum of the average cost curve. The reason for this is that in the long run, all costs are variable. And so if the firm needs to be able to cover all of their variable costs in order to justify continuing to produce, they have to be able to cover all of their costs. Now, this actually has some important implications. That is, the position of the shutdown point in the long run has some important implications. Because in the long run, we assume that firms can enter and exit from an industry. And what that means is that competitive forces tend to have an impact on the price at which the level at which we observe price in the marketplace. Now, to get an idea of what's going on here, we need to think about entry, exit, and long-run supply. If price were above the minimum point on the long-run average cost curve, then what that would lead to is what's called excess economic profits. These excess economic profits will attract new firms. This is simply an entrepreneurial response to the fact that there's money to be made in an industry. Those new firms will continue to enter until the increase in the quantity supplied drives the price of the product back down to equal the minimum of the long-run average cost curve. What's going on here is that as firms observe economic profits, they enter. Their entry brings with it new supply. When that new supply is added to the existing level of market supply, that tends to put downward pressure on price. That will continue until the price is just at the minimum of the long-run average cost curve. Now, the reverse is also true. If price were less than minimum of the long-run average cost curve, then in fact what will happen is that firms will lose money. Firms that lose money or that have economic losses will eventually have to leave the industry. When firms leave the industry, that is to say when they exit, that reduces the total quantity supplied, and that tends to drive the price of the product up. It puts upward pressure on price until that price reaches the minimum of the long-run average cost curve. We can illustrate this in the context of a diagram that shows average cost and marginal cost for an industry. I'll give you a few minutes, or you might want to pause the video to draw these diagrams. Now, what I want to get across is that in the long run, we know that this point will be the shutdown point. At any price less than the shutdown point, we know that the firm will choose not to supply. And so the highlighted black portion of the left-hand side axis shows the portion of the firm's long-run supply curve below the shutdown point. However, any point above the marginal cost curve above the shutdown point will be part of the firm's supply curve as well. And so that black line represents the overall segments of the firm's long-run supply curve. If the price were equal to, let's say, $5, the firm would continue to choose to produce, and it would choose to produce at a point where price equals marginal cost. And that would lead to a level of output. Let's just call it Q1 for the sake of argument. Well, if a firm is producing at Q1 and they're receiving a price of 5, they're actually earning a profit. Now, we know they're earning a profit because their average cost of production at Q1 is less than the price that they receive. In particular, the average cost of production can be read by following the blue dotted line up until it just hits the red line, the firm's average cost curve. At that point, we can identify what the level of average cost is, and that's this blue horizontal line. The difference between price and average cost at that level of production is a margin. That margin times the level of output is equal to the economic profits that the firm is earning. So this dark shaded area represents the area of economic profits that the firm would be earning if the price were equal to $5 and if they chose to produce Q1 units of output. Those profits will attract entrants. Those new entrants will bring with them supply, and that will put downward pressure on price until such time as it's just at the shutdown point. Now, let's think about what would happen if the price were equal to $4. Well, if the price were equal to $4, the firm is going to choose to produce at a point where price equals marginal cost. That is to say, if the firm decided to produce. In fact, what will happen here is that because the firm has decided to produce Q2 units of output and they're receiving the price of $4, they actually have a loss. And the reason why they have a loss is that the price that they receive is less than the average cost of each unit that they're producing. To see this, follow the blue dotted line from Q2 up to the red line that represents average cost. Where the blue dotted line at Q2 level of output intersects with average cost, that tells us the average cost of production for this firm. And in fact, since the average cost of production is less than the price, we know that the firm is making an economic loss. In those instances, firms would exit. And that exit of firms would then reduce the amount of supply that's available on the marketplace, and that would put upward pressure on price. And price would then continue to rise until it hits the minimum of the long-run average cost curve. This is a really important phenomenon because these competitive pressures that firms face, either the entrant or the exit that firms face, that actually results in prices in the long run equaling the minimum of the long-run average cost curve. And that actually leads us to a concept of what's called long-run equilibrium. And the idea here is that for a competitive industry, you see a long-run equilibrium when the output price is equal to the minimum of average total cost of all firms. Now, one of the consequences of this is that in the long run, and in the long-run equilibrium, all firms earn zero economic profits. That's not to say that there's money not to be made. It's just that after we account for explicit and implicit costs and a return to the entrepreneur and a return to management and ownership, there's nothing to be made. There's no residual profits that are left over. This is actually a very important phenomenon because we think this is what governs how markets react to prices in the long run. Now, if firms have identical long-run costs, and competition drives individual firms to produce at the minimum of the long-run average cost curve, we have some implications with respect to what the long-run supply curve looks like. Page 11 of the notes has space for you to draw a diagram. And what we're going to do is we're going to add up individual firm supply in the long run to derive a long-run market supply curve. And as it will turn out, that long-run market supply curve, given the conditions that I've just described, is horizontal. That is to say, it's perfectly elastic. To illustrate this, page 11 has room for you to draw this diagram. You might want to pause the video and draw the average cost curve and marginal cost curve as I have, as well as that dotted line. Now what's going on here is that we know that in the long run, the shutdown point is going to be here. That's where marginal cost cuts the minimum of the average cost curve. We also know that for the firm, part of the supply curve will be this portion of the price axis. Make sure that you note that it's that portion of the price axis for the firm that's below the shutdown point. That portion of the supply curve that represents zero output, that is the portion below the shutdown point, will also be part of the supply curve for the market. And I've drawn it on the right-hand side of the diagram. Now, what's going on here is that the idea that, okay, through competitive forces, all firms, if they're going to choose to produce, will be producing at the point where price is equal to marginal cost at the shutdown point. So all firms would be producing at that little black dot at the minimum of the average cost curve. If we add up that supply across all firms, what we would end up with in the marketplace is a sequence of dots all along that dashed line that represents price. If we connect all of those dots, we end up with what's called the short run or the long run supply curve. In this case, it's perfectly elastic. It is horizontal. And this simply reflects the fact that we've assumed that we have identical firms that are all price takers. If we relax either of those assumptions, the situation could change. For instance, it's sometimes the case that these long-run supply curves are upward sloping, in which case we say we have an increasing cost industry, or they're downward sloping, in which case we say we have a decreasing cost industry. Now, we're not going to talk much more about how we derive these supply curves. I want to make sure that you have the intuition to understand that they come from the behavior of individual firms and that they're aggregated up to a market level. We're going to use those supply curves in the context of trying to understand a little bit better the functioning of agricultural and food markets, both in the developing country and in developed countries. Before we do that, I want to talk about one more little bit of profit maximization, and that's actually in the context of the choice of inputs. So up till now, when we've been talking about supply and profit maximization, we've been assuming that the firm is choosing a level of output. But we can actually look at profit maximization through the lens of how much input should I use in order to maximize profit. And to do that, what we're going to do is assume that we have one variable input and a three-stage total physical product curve. And we convert that total physical product curve to something called the value of total product curve, or VTP. We do that by multiplying TPP by the output's price. The cost of the variable input equals the amount of the input used times the input price. On page 12 of the notes, there's space for you to draw a diagram that I'm going to go over in a few minutes. What we're looking for is the profit maximizing choice of inputs that maximizes the difference between the value of total product and the factor cost, that is, the cost of the variable input that I'm using. This is the diagram that you should be drawing on page 12. You might want to pause the video and draw this and make note of the fact that on the x-axis in both panels I've written out labor, that is to say we're dealing with an input to some sort of a production process. Now if I multiply TPP by price, I end up with this green line, and that's simply the value of total product curve. And so that's the value of the output coming through this production process. So at any given level of output, I can calculate my corresponding total physical product, and if I multiply that by price, I get value of total product. The red line represents what's called total factor cost. You might think of this as a total cost, but really it's only about the cost associated with using the input labor. And so we make sure to call it a total factor cost to represent that it's about the cost of using one factor of production. And this is simply the wage rate times the amount of labor that I'm using, and I've represented that here with an X. If I subtract total factor cost from the value of total product, that is VTP minus TFC, I end up with profit, and I've drawn the profit curve in the panel in the bottom. And what you'll notice is that it's increasing over a range of labor uses, reaches a maximum and then declines. And as you might anticipate, what we're interested in is in the level of labor that maximizes profit. In this particular case, it would be L star. And at L star, the gap between VTP and total factor cost is at its greatest. What's also true at L star is that the slope of the value of total product curve is equal to the slope of the total factor cost curve. I've represented the slope of the value of total product curve with this blue line. And I've drawn it parallel to the total factor cost line because their slopes are equal at that point. Now the slope of the total value product curve has a special name. We call this value of marginal product. And the reason why we call it the value of marginal product is that it shows the dollar value of marginal physical product. So the slope of VTP is simply price times marginal physical product. Now, we can also draw this kind of diagram in the context of the value of marginal product and the value of average product. To do that, we're going to change gears a little bit, and we're going to draw a diagram that I think you have space provided for on the last or second to last page of the notes. And here what I'm going to do is draw the green line, and that's called the value of marginal product. This is simply price times marginal product. I'm also going to draw this red line. This red line is value of the average product, or VAP, and that's simply price times average physical product. So what I've done is I've taken the graph that has APP and MPP, and I've multiplied the APP curve by price to get value of average product, and I've multiplied MPP times price to get the value of marginal product. Now, in order to determine the profit maximizing level of input, what we need is a price for that input. Now, because we're dealing with labor, let's assume that we have some wage rate that's represented by W, this dashed line. What the firm would do is it would try to equate the value of marginal product, that is the value of the marginal product produced by that labor, it would try to equate that to the wage rate. So it's looking for the point where wage rate is equal to VMP. As drawn, that would occur here at L star. This would also be the profit maximizing level of input use in the previous diagram, and that occurs at the point where the slope of the total factor cost curve is exactly equal to the slope of the value of the total product curve. This is not by accident, because remember, VMP is the slope of the value of the total product curve, and W is the slope of the total factor cost curve. And so what I'm looking for is the point at which those slopes are equal, and that happens at only one point in this diagram, and that's where the firm would choose to produce. Now, as we vary that wage rate, we're going to then have different levels of input use. But that doesn't mean we're going to use input use throughout the entire range of possible values of labor. And indeed, as you vary that price, as it goes up, for instance, there comes a point where it is no longer economical to employ labor. For instance, if the wage rate goes above the peak of the value average product curve, you would actually be losing money on every unit of worker that you would employ. But for any wage rate below the peak of value of average product, you're actually earning additional profits. And so because of that, you would only choose to employ labor if the wage rate were below the peak of the value average product curve. And so that means that this thick black portion of the line covering the value of marginal product is actually part of the input demand equation for labor. If the price were to go above the peak of the value average product curve, you would then also choose not to produce with that labor. You would choose no labor. In that case, L would equal 0, and the portion of the price axis above the peak of the value of the average product curve would also be part of the input demand equation. So if you faced a wage rate of W that's high now, you would optimally choose not to use labor. I'm going to go over this in lecture and try to illustrate this with a couple of examples that show actual input demand equations derived in this way to illustrate how it gets used. So I look forward to seeing you in class, and make sure that you come to class with questions to help clarify any problems you might be encountering.